So for number 12, we're just writing the symbolic form for these definitions and statements. So for A, we have the definition of f as continuous at A. And we know that for f to be continuous at A, it means that the limit of f of x as x approaches A must be equal to f of A. So for this one, we're going to say that for all x and A belonging to the set of real numbers, we have that if f is continuous at A, right? So if f is continuous at A, or rather f is continuous at A, if and only if we have that the limit of f of x equals f of A, right? As x approaches A. Yeah. So this is pretty straightforward. I'm not going to use the super technical definitions of continuity with limit like the epsilon delta. I'm just going to do it in a more straightforward kind of way. So we're just saying that for every x and A belonging to the real numbers, if f is continuous at A, then that means if and only if the limit of f of x equals f of A as x approaches A. So for B, the mean value theorem, so we're saying that for the mean value theorem, if f is continuous on the closed interval AB and differential on open interval AB, then there is a C between them, right? Such that the derivative at C is equal to the slope of points A and B. So here we have for all A and B belonging to the real numbers, we're going to say if f is continuous, I keep writing if, but it's just if f is continuous on A, B, and f is, and I should put an extra bracket here, f is, and f is differentiable on A, B, we're going to say then, if this happens, then there exists a number between them, right? So there exists a C belonging to the real numbers such that C is between A and B. So we have C is between A and B, and that the slope between the points A and B, so the slope we have f of B minus f of A over B minus A, this is equal to the derivative f prime, this is equal to the derivative at C, f prime of C, yeah. And then let me close these parentheses, yeah. So here we're basically saying, hey, for all A and B's that belong to R, if f is continuous and differentiable on that interval, then there exists a number between them such that the derivative evaluated at that number is equal to the slope between A and B. And lastly, for C, we're going to write the symbolic form of the definition. So once more, we're not using the super rigorous epsilon delta definition. We're just using that the limit at A of f of x, right? The limit as x approaches A is equal to L if and only if the left and right-handed limits at A are also equal to L. So here we're going to say for all x and A belonging to the real numbers, the limit of f of x equals L as x approaches A, if and only if, right? If and only if, and then here we have limit of f of x equals L as x approaches A from the negative side, and limit of f of x equals L as x approaches A from the positive side. And let's just close this bracket and that bracket. Yeah. So we have put our A, B, and C. So hopefully you guys could see a symbolic form of these definitions and statements.